Okay, we're looking at a linear equation that says 4x plus 5y equals 20, and we are going to complete some ordered pairs. One thing you have to remember is that ordered pairs come in the form of x and y. So here, this first problem is telling us that x is 0. So we're going to write the equation 4x plus 5y equals 20. But we already know that x is a 0, so if I use a 0 right there in place of x, 4 times 0 is 0. And I am going to solve the rest of this equation for y. And now I just have 5y equals 20. I'm going to divide both sides by 5, and I'm going to get y equals 4. And that's going to solve the first problem of my ordered pair. So one ordered pair I have is 0, 4. So the next one is x and y, but they don't give me x, but they do give me that y is 0. And so we're going to rewrite that equation 4x plus 5y, but where it says 5y, it's going to be 5 times 0. That equals 20 also, because that's what the equation says. And now I have a new equation that says 4x equals 20, and when I divide both sides by 4, and the 4's cancel out, I end up with x equals 5. So x equals 5 when y equals 0. Now the last one's a little bit trickier because they give me x, but it's an actual value. It's not going to be 0, so I'm going to have to multiply that out. So the equation says 4, I'll write it over here, 4x plus 5y equals 20, but in place of x, I'm going to put a negative 5. So when I do that, 4 times negative 5 is negative 20, plus 5y equals 20. And now it becomes a two-step equation. And if we don't touch the variable first, we have to get rid of negative 20. And the way we do that is by adding a 20 to both sides. So I'll put a plus 20 there and a plus 20 there. And what I now left with is 5y equals 40. And now we just divide both sides by 5 to get rid of that. We'll isolate y. And y equals 8. So what that tells us is when x is negative 5 and y equals 8, that would make this equation true. And so that's the last ordered pair on the graph. So this equation is pretty basic. It just says x equals a negative 7, and what that means is it doesn't really matter what y is. X will always be a negative 7, and so when these ordered pairs are all missing an x, guess what? They're all negative 7. And if you were to put that on a graph, for example, if I had an x and a y-axis, and I had to plot those points, this would say go left 7 and up 4. It might be a dot, something like that. And this would say go left 7 and down 3, and it might be a dot down there. And this would say go left 7 up 0. And what you end up with is a vertical line that goes straight up and down at x equals negative 7. Sometimes we end up with an equation where x and y are not on the same side, and this right here is actually something that is called slope-intercept form of looking at a linear equation. We have y all by itself, and we're going to actually take these values here. We're going to take the two x's and do them first. Here x is a 0, so we'll do this first, and then we'll do this one second because it's just a x. So we're going to have y equals, and we're going to copy down the negative 3, but in place of x, we're going to put parentheses, and the first one's going to be a 0. So we'll put a 0 right there. That's negative 3x minus 3, and negative 3 times 0 is 0, and that's just 0 take away 3, which is just negative 3. And so that tells me that when x is 0, y is a negative 3, and that is one ordered pair that goes on the graph. So let's go ahead and take the second one. We're going to do the exact same process, but in place of the 0, we're going to put a 2. So that's going to be y equals negative 3 times 2, and then minus 3 again. So we'll take away 3, and negative 3 times 2 is negative 6, minus 3. And two negatives, we just add that up and we get negative 9. And so when x is 2, y is a negative 9. And now we're going to reverse the process. They're going to give us y, and we're actually going to have to solve an equation for x. So let's take those two, and we'll do that in a little different color pen. We'll do it in orange. So in this case, y was, let's do the 6 first. That seems like it's a little bit easier. So in place of y, I'm going to write a 6. So y is 6 equals negative 3x minus 3. This is just a two-step equation. Let's solve it for x. So we'll cover up we don't touch the negative 3x first. We get rid of the 3, the negative 3. We add 3 to both sides. And that's going to give me 6 and 3 make 9. And over here is negative 3x. And the last step is to get rid of the negative 3. We divide, so we'll show that with a fraction. We'll divide both sides by a negative 3, and we're going to get x equals a negative 3. So that was the 6. So when y was 6, x is a negative 3. And let's do the last one. Y in this case is negative 12. So I'll do it right over here. In fact, let's pick a different color that looks a little bit more special. And here, y is negative 12. So I'm going to put in negative 12 equals negative 3x minus 3. So everything else stays the same. I just had to replace y with a different number. Again, we're going to cover up the minus 3x. We're not going to touch it first. We'll get rid of the negative 3. So we'll add 3 to both sides. And on the left side, that gives us a negative 9. And on the right side is just negative 3x. And last but not least, got to get rid of the negative 3. We divide because that's multiply, and we got to undo it. And negative 9 divided by a negative 3, those go away. And we get x equals positive 3. So when y is negative 12, the equation tells us x is 3.